Okay guys, today we're going to be looking at lesson 51 together. I'm going to make a separate sheet up here because I just want to make a few notes about the lesson. Okay, so I'm going to write down 3 different first degree polynomial equations. The first one is going to be y minus 2x plus 1 equals 0. And I want you to be thinking about what makes these first degree polynomial equations. And then the second one is x minus 4 equals negative 2y, and then x plus y equals 0. Okay, so for each one of these, they are first degree because the highest exponent on any one of those terms is a 1. So it's a first degree equation. Excuse me. And for each one of these, I could find an x and a y value that would satisfy each one of those equations and make it true, right? We've learned a few ways of doing that. And then once I know what the x and y values are, then I can use those to make ordered pairs, and I can graph those onto a coordinate plane, and you'll see that equation and what it looks like graphed. Now, because these are first degree, these are all going to make linear equations or a line. All 3 of these. Okay, so we've learned a few different ways on how we can actually find the x and the y values to an equation. So let's just look at one of these as an example. So I'm going to take this one here and use it. So I have y minus 2x plus 1 equals 0. Okay, well, the first thing I want to do is I want to flip this thing around so that y is equal to something. So I would I would add 2x to both sides. It would make 2x on this side, subtract 1 from both sides. Okay, so those equations are exactly the same. So then I would make my x and y table. Remember how we used to do that? And I would simply pick a few, a few x values. I would plug those x values in and I would come up with my y values. So if I put a negative 2 in there, for example, I would have negative 5. If I put a negative 1 in there, I would have negative 3. 0 would give me a negative 1. 1 would give me a 1, and 2 would give me a 3. And now I have all these nice, neat little ordered pairs that I can simply graph or plot onto a coordinate plane and then connect them and make a nice line. And if I did that, I'll just try to sketch it on here really quickly so you can see. So I have negative 2, negative 5 is about down here, negative 1 and negative 3 is about here, 0, negative 1 is here. It's not looking too good, is it? But anyway, you get the idea. I didn't draw this too great. But they should be straight. Oh, that's because this isn't. There we go. So I have a line that would look something like that. Okay, it would be straight if I had this actually on a nice, neat coordinate plane. Okay, but that's how we have done these in the past. So we can use a table. And remember, one of the things that we learned in the last lesson is that x is the independent variable and y is the dependent variable. Remember, because I can choose anything for x, but y depends on what x does to the equation. Okay, so we have an independent variable and a dependent variable. All right, so let's go back into our notes down here. I want to put a couple of things in here for us. The first degree, yeah, there we go. Okay, 51. Okay, a first degree polynomial equation with 1 or 2 variables, typically x and y, is called a linear equation. A linear equation. So just write right here that first degree equations always graph a straight line. Okay, so if you come up with something that looks like it's all over the map, something isn't done correctly. So that's kind of a good indicator. Now, I want to move down to the next thing here. This should look familiar to you. Y equals mx plus b, where m is equal to the slope and y is the y-intercept. We're going to spend a little bit of time on this today so that we don't have to always do all of this work with graphing. We can take this particular format of an equation, y equals mx plus b, and pull out those parts to graph it if we just know the slope and we know the intercept, the y-intercept. So right below that, I want you to put begin the graph. We always start with the y-intercept. I'm going to actually put that in red to match it. Begin the graph with the y-intercept. And then move using the slope to find another point on your coordinate plane, and then connect those, and you'll have made the line. So let's take a look at what that looks like. The next example I want to show you, and this is not in your notes just yet. Let me just show you this. Sorry, I keep forgetting which way I need to go. Here we go. Okay, let's say we have y equals -1/2 x plus 2. Now, those of you that were with me in that first algebra book that we were using, the Envision curriculum, you've already seen these, and hopefully this will be a review, and you'll be like, oh, yeah, I remember this. So let's look at the format of this. What form is this in? This is actually in slope-intercept form. Why? Because it has a slope, and it has a y-intercept. Y equals mx plus b, where m is the slope and b is the y-intercept. All right, so I can take those now and put this onto a coordinate plane. My x-axis and my y-axis up top. Excuse me. So let's first, what did our notes say? Our notes told us that we first start with graphing the y-intercept. That's the first thing we do. That's what it says right here. Begin the graph with the y-intercept, and then we'll move using the slope. So let's graph the y-intercept. The y-intercept, we said, is 2. So how do I do that? That means my point is always 0, 2. Another way to think about the y-intercept is it's the y value of the y-intercept. So when you know that the y-intercept, or you have this number right here, is our y-intercept, that's going to be the y value in the set of points. X will always be 0. Okay, so let's graph 0, 2, right here. And from that point, we're going to find the next point using our slope of -1/2. So if the slope is m equals -1/2, remember that the slope is always rise over run. That's something you're going to always see when you're graphing equations, particularly linear equations here. And so we're going to rise, so we go back to the point we plotted at 0, 2, and we're going to rise. We can either rise -1, or I could put the negative on the 2. It doesn't matter. The whole fraction or the whole slope is negative, which means that my line is going to be heading in a negative direction. So let's go ahead. We're going to rise. I'll go ahead, since my negative is looking like it's on my 1 more so than on the 2. I'm going to rise a -1. Rising goes up or down. Running goes left or right. So this is left or right, and this is up or down. Since it's negative, we're going to rise down. So let's go down one spot. Let me get some more lines on here. Okay, so I'm going to rise from this point. Let me change the color of my pen. I'm going to rise from this point that I've already plotted down 1. So I'm going to go right down here. And I'm going to run 2 from that spot. So 1, 2 is right here. So I'm going to plot my point right here. So that second point, using my slope of -1/2, I managed to actually get another point plotted. So now I have 2 points, and that's all it takes to connect and make a line. So I would simply draw my line right through those points, and there's what that equation looks like using the slope-intercept. Let's try another one. Let's say we have, let me put another sheet of paper in here. All right, let's say we have y equals -x, and I want this to be in this form. This is the y-intercept. Slope-intercept form. And it's enough information, if I have the slope and the intercept put into that equation, it's enough for me to know how to plot it onto a coordinate plane. So I'm going to go ahead and draw my coordinate plane, get some axes here. I have an X and a Y. Okay. Just get a few lines on here. So let's look at this funny equation. I have y equals negative x. Holy moly, I don't have enough to actually pull out a slope or an intercept, do I? Well, actually, yes, I do. Because what is the m value here? The m value would be right there. Isn't that it right there? If I stick a 1 in there, mx is negative 1x. Well, what is b? There's nothing there. So it would be a 0. So now I have enough that I can actually plot. So I always start with, remember we were told in your notes, to graph it, we start with our y-intercept. So the y-intercept, we use this 0 and we make a new point. Remember the x value will always be 0 and the y value is actually this. Okay, so let's graph 0, 0. That's our first point. It's right there at the origin. And from there, we will find the next point. We're going to use our slope. And remember, slope is negative 1. It's the m value that's the coefficient of x. Okay, so our slope is always rise over run. Well, I have a negative 1. So I have, this time I'm going to put the negative 1 on the bottom. It's 1 over, negative 1 over 1 or 1 over negative 1, or, you know, it's like this, but only one of those would be negative to make the whole thing negative. Okay, so this time I'm going to put the negative on the bottom. It doesn't really matter as long as you're rising and running in the proper direction. So remember, rise is up or down. So I'm going to start at my point and I'm going to rise up 1. Rising up 1. This is a positive 1. And then I'm going to run negative 1, which means I'm going to run now to the left because left is negative. Just one place from where I managed to get when I rose. So there's my second point. And I can draw my line. And again, it's a negative slope. Okay, now let's talk about a vertical and a horizontal line. We talked about these as well. I don't know if you remember these. I showed you a video of a crazy man who was drawing on the board, remember, and he was drawing a dandelion. I actually could probably show that to you in class, or maybe before I end this video, I'll play it for you. But let's say we have x is equal to negative 2. What does that look like on a graph? Well, if I look at my x-axis, now let me show you. If x is negative 2, what that means is x is always going to be negative 2. So I'm going to draw this line. Let me show you. It's supposed to be going right through negative 2. This is negative 2 right here. So let's look at each one of these points. If I were to draw some little tick marks on here, and I said, let's name this point, I'm sorry, not those points. Let's name this point, let's name this point, let's name this point, let's name this point. There's 4 points. Let's just give them their name. So where would that be? That would be at negative 2, 1, 2, 3, negative 3. What about this one? Negative 2, negative 1. What about this one? Negative 2, 0. What about this one? Negative 2, 1, 2, 3, 4. But notice the x value is always negative 2. It makes a vertical line, and that's what that means. X is always negative 2. Well, what about when we have something going across on the y-axis? And I'm going to go ahead and do this one in red. What if I have y equals 4? What is that going to look like? Well, that one's going to cross the y-axis at positive 4. So that one's going to look like this. So if I asked you to define a few points on the line, and I said, well, what is, let me get rid of this one here. Trying to erase, didn't manage to do it well. Okay, let's go back and get my line put back up there. Okay, let's say that we wanted to name a few points on this line. So let's see, let me put a couple more lines over here. Let's say I wanted you to identify the ordered pair for that one. We'll go ahead and leave that one there. How about this one? We'll just do 3. Okay, so what is this one? 1, 2, 3, 4, so -4. And what's the y value? 1, 2, 3, 4. What about this one? This one's at -2, 4. What about this one? This one's at 3, 4. But notice that the y value is always 4. That's how we graph y equals 4. So when you see a vertical line, it's going to be an x equation. And when you see it horizontally, it's going to be y equals some value. Okay, so I'm going to entertain you by, I think I may have this video up because I watched it not too long ago. So give me just a moment here. I'm going to share my screen with you once I find it. YouTube, where are you? Sit tight just a moment. Ah, there he is. Okay. Let me come back to I'm not sure I know how to share my screen here. Maybe you can see it. I don't know if you can see it. Can you see it here? Maybe.
Let's name a couple of points on the I got the cheap and easy for you people. I'm talking about graphing horizontal and vertical lines. Let's look at this line. Is that horizontal or vertical? Horizontal. Let's name a couple of points on this line. What's this point right here? That's the point 0, 5. What about this point right here? That's the point 3, 5. What's this point here? That's the point 5, 5. But wait, there's more. What's this point right here? That's the point -3, 5. But wait a minute. Do you have an observation? Can you see what I'm saying? Or did it fall on deaf eyes? What? You can't have deaf eyes. You also can't really see what I'm saying. Anyways, back here, man, my observation. The y value is always 5. You could say that y is equal to 5. Wait a minute. That's the graph of y is equal to 5. Because y is always 5. Let's go to this example. Oh boy. How do you draw this one? Y is equal to -2. Well, that's what y is equal to -5. So you know y is -2 right there. You draw the line. Whoa, a little too far. Let's see if we can explore and extend those ideas. X is equal to 3. Is that here? No. Is that here? No. Is that here? No. That's here. So you do one of these. A box. And a flower. That's not a flower. That's a weed. What kind of weed is that? It's a dandelion. And you know why? Because this one's a dandy? No. Because these are the ones that you wish for.
Okay, so hopefully you got to see that. That was kind of silly. But anyway, it just gives you an idea. It might help you to remember what to do with a horizontal and a vertical line. Okay, so hopefully that helps. And you guys can go ahead and start on your practice set of problems. I think we have one more thing actually to fill in down here. I just noticed we did not do it. So let me go back up here. And let's get these examples on here real quickly. So let's go ahead and graph these, and then you guys can do your practice problems. Okay, so let's look here. So I have these problems are actually, this particular one is in y equals mx plus b format. Okay, so let's figure out the parts. What is m equal to? Well, m is the coefficient of x. So our slope is going to be 1/4, which remember we said is rise over run. So we're going to use that in just a moment. What is the b? The b is -3. So that's my y-intercept. So what is the y-intercept? The y-intercept, remember, is always an x value of 0, and b is always the y value in that set of ordered pair, So let's go ahead. We start by graphing this first. So 0, -3 will be right here. Remember, a y-intercept is always on the y-axis. An x-intercept will be on the x-axis, but we're only really concerned right now at this moment with the y-intercept. Now from there, we can graph the next point on our line. We use our slope, which is 1/4, which is rise over run. So we're going to, let me write that over here. So we have rise over run equals 1/4, or 1/4. So we're going to rise up 1. So I'm going to change the color of my pen to red. We're going to rise up 1. We went into a positive direction, 1 step, and we're going to run over 4. 1, 2, 3, 4, plus 4 steps to the right, and my second point will be right there. So now I can graph this line. It's a positive slope, isn't it? It's heading. How do I know if it's negative or positive? Well, I always think of it this way. You always start at the left-hand side of your line. You put your eyeball right there, and you look. Which direction is your eye looking? It's looking up, so it is going in a positive direction. Let's look at this one over here. This one is also in y equals mx plus b. These are the best kind to graph. It makes it so easy because we can pull 2 pieces of information from this. So what is my slope? My slope is always the coefficient of x. It's what m is in this form. So the slope is -2, which can be -2/1, right? That's rise over run. Or you can put the negative on the bottom. It doesn't really matter. It can be like this. It doesn't really matter. It matters, though, that only one of them is negative because when you're rising and running, it will make a difference. Okay, what is the y-intercept? The y-intercept is this right here. And remember, it's going to be on the y-axis, and we use that one as the y value in this ordered pair. So the first thing we start with is we graph the y-intercept at 0, 1. So let's go do that. Here's my y-intercept, and from there, I'm going to use my slope, which remember is rise over run, and I'll go ahead and leave it with the negative on the bottom. Let me change the color of my pen. So I'm going to rise up 2 from this point. 1, 2. I went up 2, and I'm going to run to the left 1 step, -1. So here is going to be the second point. Connect those 2 points. Didn't do a good job of getting those connected very well. But look at this one. Which way is this heading? We know we have a negative slope, so it has to be going negative. But how do I know by looking at it? Well, again, I go to the left side of my graph, or my line, and I look. Which way is it going? I'm looking down, so it's heading in a negative direction. So that is a negative slope on that equation. And that's how you graph linear equations. Okay, guys, go ahead and start working on you have a few practice problems here that you're going to graph. Check those out, and then you can start on the lesson.